All right, so now that we know a little bit about the ambiguous case, let's see how we can use it to solve a triangle. So let's solve triangle ABC with the following measurements. B will equal 4, A will equal 2.5, and angle A will be 58 degrees. All right, so here's sort of the sequence of questions you should ask yourself with these kinds of problems. First of all, you need to realize what kind of triangle this is. Okay, so if we go A, B, C, and we label what we know, so A is 2.5, B is 4, and A is 58. Okay, this is an angle, no, let's do this the other way. Let's be nice about this. This is a side-side angle triangle. That's the information we're being given, is two sides and a non-included angle. And this is the only situation where we get the ambiguous case. So if you have any other setup, if you're given a side angle side where the angle is included between your two sides, if you're given angle side angle, anything else, this whole ambiguous case doesn't make any difference. There is no ambiguous case in the other situations. It's only in an SSA triangle that we can possibly have the ambiguous case. Okay, so you first need to identify that yes, that's what I'm dealing with. Then you need to take a look at what kind of angle they've given you. They've only given you one, and it is based on that that we decide whether we're going to look at the acute possibilities or the obtuse possibilities. So our angle in this case is 58 degrees. That makes it acute. Okay, so we know we're looking at the possibilities on our foldable when A is acute. Now, there are 4 different possibilities there, and when you look at them, you'll notice that 3 of the 4 have H involved. One of them is only concerned with A and B. So that is your first question. Is A actually greater than B? And the question is no. A is a 2.5, B is a 4, no. So if not, then we're going to have to figure out what H is, because for the other 3 possibilities, H is involved. And so for H, we're going to take the B value of 4 times the sine of angle A, which was 58 degrees. Okay, and when you plug that into your calculator, we get an H value of approximately 3.39. Okay, so now, how does our A value compare to H? Well, our A is the 2.5, our H is the 3.39, and so A is less than H. And when you look at the other 3 possibilities for when A is acute, we see that when A is less than H, there are no triangles possible. Which means that if you have these 3 measurements to start, there's no possible way that you can make a triangle out of them. So we cannot solve this triangle because there are no triangles that can be created with these 3 measurements. Okay? All right, let's take a look at another possibility. Let's say we want to solve triangle ABC with these measurements. We have angle A equal to 70 degrees. We have side A equal to 155. And we have side C equal to 160. Now let's go ahead and just make that a B just for simplicity. Okay? So again, when we think about where those measurements are on the triangle, we have side A of 155, side B, which is at 160, and angle A, which is 70. So again, we can see we're dealing with the SAA case, where we have two sides and a non-included angle. Okay, so again, first thing we need to identify is what kind of angle are we dealing with. And a 70-degree angle is going to be acute. Okay, so out of the four possibilities when A is acute, we're first going to ask ourselves, is A bigger than B? Well, again, A is 155, B is 160, so that answer is no. So when that answer is no, then we have to find H, because in the other four possibilities, H is involved. So that means we'll be taking the 160, our B value, times the sine of the 70 degrees. And when you put that into your calculator, it gives you approximately 150.35. So now when you compare your A value to H, we can see that our A is actually bigger than H this time. So it's not bigger than B. That means A is less than B, but bigger than H. That's when we get two triangle possibilities. Okay? So when we set this up, I'm going to want to set up two tables to fill in, because there are two different ways that a triangle could be created with these three measurements that we've been given. And so we have to come up with the total measurements for both of those triangles. We have to solve both possibilities. So in both of them, we'll fill in what we know. We know the 70 degrees for A. We know it's 155 for side A. And we know it's 160 for side B. Okay. So now, when we go to solve this, the first thing we're going to solve for is angle B. And for angle B, we're going to set up our law of sines. So the sine of the 70 degrees over 155 will equal the sine of whatever B is over 160. Okay, now notice where our variable is now. Our variable is the angle measure. So we're going to take 160 times the sine of 70. We're going to divide that by 155, but that gives me the sine of B. In order to get B, I'm actually going to have to take the inverse sine of all of this. Okay, so let's go to our calculator. So I'm going to go ahead and take the 160 times the sine of 70, divide that by the 155, and get my answer. Now again, that came out in a trig form, so I'll do a Control Enter to get the decimal answer because that'll be a little easier to work with. And so we're equal to about 0.970005. But that's what the sine of b is equal to. So now I need to do the inverse sine, which is in your trig menu. And for inverse sine, I'm just going to do the previous answer. So that's Control and your negative sign here right beside your enter. See how it has ANS there? So that's previous answer. And now when I hit enter, it's taking the inverse sine of that previous answer I had, and it's giving me a 75.9 if I round it off to the nearest tenth. So that means my B angle is a 75.9 degree angle. Okay? Now, here's where I have to consider my second triangle. Because if you remember in our previous video, when I have the two possibilities, in one possibility, angle B is acute, and that's what we've just found here, 75.9. In the other possibility, my angle B is obtuse. And so in order to find angle B here, I need to take the 180 minus the 75.9 degrees that I just found here, because I need the supplement for this angle B. So here's going to be the 75.9, which is what the calculator gives me, and we know from last chapter that the calculator can only give me one answer. But I can use that to get other possibilities. And so when you think about sine, the other place where we get sine, I can get that by taking the supplement here and take 180 minus 75.9, and that's going to give me an angle of 104.1. So that's where the big difference comes, is in that first step. When I find B here, and I find the possible acute angle that's going to work here, I then take the supplement of it, and that gives me the obtuse angle that's going to work in this second possibility. And now I'm going to solve the rest of the triangle in each case with the given value that I have. Okay, so in this case, I can now find angle C by taking 180 minus 70 minus 75.9, and that gets us a 34.1. So that's angle C. I can do the same thing here, but now what I'm subtracting is 180 minus 70 minus the 104.1. And so here I get a very tiny angle of 5.9. Okay, degrees on both of those since they're angle measures. So my process isn't changing, but the numbers I'm using are going to be a little bit different, and that's what's going to affect my overall solution for each triangle. Okay, and then finally, to get side C, in this one I'm going to set up the law of sines, where I'll have the sine of 70 over 155, and that's going to equal the sine of my 34.1 over C. Okay, so again on our calculators we're going to be taking the 155 times the sine of 34.1 and then dividing that by the sine of 70. Now here, notice I have both angles, so I already have the sines of these. C is what I'm trying to find. C is just a side, so I don't have to do any inverse sines on this one. Okay, so on our calculator we'll take our 155 times the sine of 34.1, divide that by the sine of 70, do a control enter so we're sure to get a decimal, and we get 92.5. Okay, now I'm going to do the same thing for this c, and I'll have the sine of 70 over 155, but now I'm going to have that equal to the sine of 5.9 over c. Okay, sorry about that, forgot to switch. So this is what I'm setting up this time. Sine of 70 over 155 is going to equal the sine of 5.9 over the c value in order to find the c that's in this triangle. Okay, so back to our calculator. 155 times the sine of 5.9. Divide that by the sine of 70. Yeah, sine of 70. Control, enter, and we get about 16.95. So if we're rounding to the nearest tenth, that's really a 17.0. This will be a 17.0. Okay, so the trick when you have these two triangle possibilities is right here. When you find this angle based on the two sides and the angle you were given, in the one case you keep the acute answer that you get from the calculator. In the other case, you get the obtuse angle by taking the supplement of this one, and then you continue to solve each triangle on its own using the values you now have. Okay? So in your next homework, the 3.1b, in that practice, all of your triangles are going to be SSA triangles. And so you will need to decide what's going on with each one. You can use your foldable to help guide you. If you have two triangles like we did here, you must show how to solve both triangles as your answer. If you have no triangle like we did in our first case, then just write no triangle and move on. And obviously, if you get a situation where there's one triangle, then you just solve it like we would normally solve it. All right, if you have any questions, please seek out help. Email me if you need to, and we will be seeing you next lesson.